Before I get into the student notes, let's take a look on how to construct a histogram. Now, a histogram is a graph that displays the data by using contiguous vertical bars of various heights to represent the frequencies of the classes. Its purpose is to provide us with a graphical display of the distribution of a data set. The following distribution represents the number of members of the 2016 United States Electoral College for the election of the president in a grouped frequency distribution. In order to create a histogram, we begin by starting with a blank sheet of paper. Notice at the bottom, the x-axis, I've listed the lower class limits as you can see from the previous distribution. Notice that the 2.5 we start with here came from the 2.5 boundary. Next, 10.5 obviously came from the next lower boundary, and so on. 18.5, next lower boundary, and I think you can see where we go from there. Now you'll notice that I end the x-axis with 58.5, which hopefully also makes sense. The vertical axis will be labeled according to the frequencies of the grouped frequency distribution. You'll notice as I go back to my distribution here, the highest frequency we have is here at 34. So as you can see, the highest number I go to is 40. That way we more than cover our frequencies. Once again, let's take a look at our table. And as we can see, we have all of our given information that we saw from the previous example. First, notice that my frequency of 34 that lands in the class of 2.5 to 10.5 creates a bar as follows. Notice that my first bar, which will happen to be the highest bar in this histogram, reaches almost to 35 but not quite. That's because it has a frequency of 34. Next up, you'll notice that we have a frequency that's a little above 10. Well, that's easy because the next frequency was 11. So clearly this second bar represents a height of 11. The next class, 18.5 to 26.5, obviously comes from the number that we have here, which is 2. Filling out the rest of this histogram, we can see that we get the rest of the bars here. And what this forms is what is known as a J-shaped histogram. In fact, more appropriately, this is known as a reverse J-shaped histogram. Now that we know how to construct this histogram by hand, why don't we go ahead and try to construct this very same histogram using our TI-84. So first, I would like to represent the data from the previous example in a slightly different way. In this table, you'll notice that we have the number of United States Electoral College members listed state by state. If you go through this table, you'll notice that there are 34 states that have between 2.5 and 10.5 members. Also, you'll notice that California is the only state that has as many as 55 members. And the point I'm trying to make is that you'll notice that this table does follow along with the data from the previous distribution. So how do we use this data to create a histogram in our TI-84? Well, first we must establish what is our class width. So after determining our class width, which we have done in previous sections, we can now proceed with building our histogram. Now, it is at this time I would invite you to pause the video here, make sure you have your TI-84 on your desk, and please follow along with me step by step. The first step is to press the Stat button, which we can see is located right here. Once you click Stat, you will see this screen pop up. And then next you'll press the number 1, or Edit. Once you click Edit, you go ahead and enter all the numbers from that previous table that you saw, state by state. Notice here that we have 55. That's the one that represented California, for example. So there should be several states here listed. As you can see, I have already entered the data into my list. I invite you to pause the video here and please enter all the data from the previous table. Once you have finished entering all the data from this table, we can continue. Now, we press the Y equals key, which is located in the upper left corner of your calculator. We need to make sure that all functions entered are turned off. They can be turned off by using the cursor to highlight the equal sign, then pressing enter. Now once you press Y equals, you will end up with this screen here. And if you bought your calculator new, chances are there will be nothing here anyway. But in case you do have something here, you do not want these functions to be turned on. The way you turn them on or off is by using this cursor to highlight the equal sign itself. And then notice how the equal sign is no longer highlighted. That's what you want. This will indicate that the function is turned off and will not be graphed. Next, we'll press the second key in order to get to Stat Plot. So go ahead and press second, then Stat Plot, which again is located above the Y equals button. Once in Stat Plot, go ahead and press 1 for the first plot. Now, we need to make sure that plot 1 is turned on. So take the blinking cursor and move it to the word on and hit enter. Make sure again that the cursor is blinking on the on selection, then press enter. Also, we want to make sure that we are graphing a histogram. So, put the cursor over the histogram icon and hit enter. The histogram icon is this icon right here. Now, cursor down and make sure the correct list is specified. If you recall, we put all of our information into list 1. So you're going to want to make sure that list 1 is the list that's being specified. Now we will press the graph button. The graph button is located in the upper right corner. Once you hit the graph button, you will get a histogram. But you'll notice that our histogram looks almost nothing like the histogram we actually graphed earlier. This is the same histogram as the previous example. So one would have to wonder, shouldn't the histogram look exactly the same? And the answer is yes. Also, you'll notice that our histogram here appears to be cut off. How do we fix this? Well, what we need to do next is we need to hit the Window button to help us get there. So go ahead and click Window, and that'll give us this page here. And what we're going to have to do is we're going to have to manipulate some of these numbers to get the window that we want in order to properly display our histogram. First, change your x minimum to 2.5. Go ahead and do that now. Next, type the cursor down and change your x maximum to 60. The reason why we're going from 2.5 to 60 is to more than cover the number of electoral college members that we have per state. If you recall, some states only have as low as 3 members, but then of course we have California with 55. We want to make sure that we more than cover these data values. Now, cursor down to scale and enter the class width. Now we know the class width was 8. So notice here how the x scale is now 8. Furthermore, y min will be 0, and the y max, you can't quite see it here, but that will be 40. And the reason why it's 40 is because the highest frequency count we had was 34. And just like the x values, you want to more than cover your y values. Once again, set the y value maximum to 40. Now we press graph. And as you can see, it matches the one that we constructed earlier by hand. Furthermore, the calculator has the ability to display the lower and upper bounds and frequencies for each class by simply pressing trace. Trace is located right here. Note the minimum and maximum values for the first class are 2.5 and 10.5 respectively. And note that the frequency given as 34 in this first bar. If you press the right cursor to advance to the next class, again, you will see the lower and upper bounds for this particular class, including its height. Now, follow along with your student notes. Make sure that you fill out the blanks and let me know if you have any questions. Now we will represent data in frequency distributions graphically using histograms, frequency polygons, and ogives. When data are organized into a frequency distribution, the summary can be presented in graphical form. The most commonly used graphs: histogram, a graph that displays data using contiguous vertical bars. Frequency polygon, a graph that displays data using lines that connect points plotted at heights representing class frequencies at the midpoints of the classes. Cumulative frequency graphs, or ogives, graphs that represent cumulative frequencies for the classes in a frequency distribution. Let's do an example. We're going to use the following table to construct a histogram, a frequency polygon, and an ogive. This information may look familiar to you, as it is representing the salaries in hundreds of thousands of dollars of a sample of 30 colleges and university coaches in the United States. We've seen this information before. Let's go ahead and use it again. Let us begin by constructing a histogram. Here are the steps. First, we will draw the axes. The x-axis will be the horizontal axis. The y-axis is the vertical axis. Step 2, we shall label the axes. The x-axis is the horizontal axis labeled with lower class boundaries. The y-axis is the vertical axis labeled with values for the frequencies. In step 3, using the frequencies as heights, we will draw vertical bars for each class. So let us begin. So on my y-axis, that's going to list the frequencies. Our highest frequency, as you recall, was 11. Let's go ahead and do my x-axis here. My x-axis will be the classes of salaries. Once I get those down, how do I start? What do I begin on the left-hand side? Well, I'm going to go to the table and take a look at my lowest class boundary, which in this case is 139.5. And that's going to be the first number that I start with. And once I write down 139.5, I proceed from there. And every tick mark is going to include my next lowest boundary, which in this case will be 229.5. Then 319.5, I believe, is next. Yes. And continue from there. Okay, once that is done, I go ahead and begin drawing my vertical bars, where 11 is my first frequency, so I'm going to draw a bar with a height of 11. And then I'll draw a bar with a height of 5. The next 3 are 4s, 0, 1, 1. Then there's 3 4s in a row. Then next is 0, so there's no height there. And the last 2, there is a height of 1. There's 1 coach per those last 2 salaries. There's my histogram. And obviously there's a nicer picture here that works. Now let's go ahead and construct a frequency polygon. So here are the steps for a frequency polygon. First, list the midpoints of each class, which we already have in our table. Next, label the x and y axes. X-axis is labeled with class midpoint. Y-axis is labeled with class frequency. Finally, at each class midpoint, plot points at the heights representing the frequency for each class. So let's go ahead and sketch one of these. So I'm going to go ahead and start with a similar looking XY axes. You'll notice that my X and Y axes actually are the same definitions. We're just going to use different points as the tick marks at the bottom of the X axis, starting with the first midpoint, my first midpoint being 184.5. But now you'll notice where I place it might be a little strange at first, but you'll notice that it makes sense after I finish the frequency polygon. We're actually going to start by placing it here. And going on down the list, our next midpoint is going to be 274.5, and so on. And actually, we're going to go ahead and add yet one more, quote, midpoint on the end here, simply by adding 90. I'll get 904.5. And the same thing on the left-hand side here, I'm going to subtract 90 from 184.5, which gives me 94.5. Next, at each midpoint, I'm going to go ahead and indicate the frequencies. So obviously here at 184.5, we have a frequency of 11. So at 184.5, I'm going to plot a point at 11. At 274, that has a frequency of 5. So we'll go ahead and plot a point at a height of 5, right above 274. And we'll continue this process for the next several midpoints. The next 3 have a height of 4. The next midpoint is a height of 0. And the last 2 midpoints have a height of 1. Now at these endpoints, at the 94.5 and the 904.5, we're just going to go ahead and place a height of 0. Now finally what we do is we go ahead and connect these dots to create our frequency polygon. And there we have our frequency polygon. Here's a bit better view of the frequency polygon generated by a computer. Let's go ahead and move on to an ogive. And that's going to use the cumulative frequency, where you'll notice that each frequency grows larger and larger as we progress from each class to class. So how did we get from 11 to 16? Well, simply we added 5 from the second class. Then 16 to 20, we added 4. And if you recall, there were 3 classes in a row that had 4. So if I add another 4, I get 24. If I add another 4, I get 28. And you'll notice I go 28, 28 twice. That's because, if you recall, one of the classes had 0. And then the next 2 classes had 1 to get us up to 30. So I'm sure that you all know how we got the cumulative frequency because we've done this before. So step 2 is we're going to label the x and y axes, and just like the frequency polygon, we're going to go ahead and label the x-axis with the midpoints and use the same y-axis labeled as the frequencies. Now this time, the frequency is cumulative, so it's going to go up to 30. Or at least up to 30, perhaps higher. Now at each upper class boundary, we're going to plot the cumulative frequency points. And we're going to start with the upper class boundary and then connect adjacent points as follows. And for this one, I'm just going to go ahead and show you a computer-generated image and just explain it. So there are some similarities to the frequency polygon, starting with the fact that we are listing midpoints. And you'll notice that we start off with a height of 11. And then when we get to the next frequency midpoint here, you'll notice now we're at a height of 16. Well, that's because we took the 11 and added 5. And it got us up to 16. And at the next midpoint, as you can see, we went from 16 up to 20. That's because we added 4 from the previous class. And as you can see, it goes up by 4 to 24 here, and then it goes up by 4 again to 28 here. Then there are no coaches in this little salary range here, so it stays flat for a second. Then it goes up by 1, and by 1 once more. And technically, you're supposed to plot these points first and then draw the line segments that you see here. That's an example of an ogive. Also, notice that this time my frequency is cumulative, so we use 35 to more than cover our 30 coach salaries. There's also something known as a relative frequency graph, and we'll talk more about this as we progress through the class. Basically, it uses relative frequencies or appropriate scale instead of frequencies itself. Again, emphasis on the word relative. Now the graphs look the same, only that the scales on the y-axis is different. Last but not least, it is also good to understand the shape of histograms. So why don't we go ahead and discuss that next. So I'm going to go ahead and show you several different types of histograms that have different classifications, which will lead to different predictions or conclusions. And these are all worthy of note, so please pay close attention. The first is called a bell-shaped histogram. Bell-shaped histograms start low, kind of have a curve up to the top, peak out around the middle somewhere, and then do the same thing on the other end, and you can see as you look out, it shapes a bell. This is known as a bell-shaped histogram. Notice that this histogram is not perfectly symmetrical, but it's somewhat close to being symmetrically bell-shaped. Next, uniform histogram. You'll notice that almost every height of this histogram are almost the same. Now, are they exactly identical? No. But all these heights are very close to each other. That would make this a uniformed histogram. J-shaped. A J-shaped histogram starts low and goes high, and usually at the end there it kind of curves up quite a bit. This one's known as a reverse J-shaped for obvious reasons. This one is known as right skewed. This one might be a little confusing for some students, but I'll explain more in the future. That right skewed simply means that most of your data is actually on the left-hand side. Notice that most of the data is on the left-hand side of this histogram. But what's trying to skew your data are all this little data over here on the right. This data on the right is trying to skew the general idea of what's happening here. Again, notice that most of our data is on the left-hand side. But this little data here on the right is trying to skew the values. It's trying to skew your statistics and inevitably skew your predictions. Same thing here, left skewed. Notice here that most of our data is on the right-hand side. But the left here, this little tiny bit of data over here is again trying to skew the overall database. Bimodal. Bimodal is simply just, you look like you have two peaks going on, essentially. We have peak number 1, and then we have peak number 2. It's almost like two different things are going on here. That's known as bimodal. Last but not least, for obvious reasons, this is like a U-shaped histogram. Starts high, goes low, ends up going high again. Almost like an upside down bell shape.